Hi, this is Nimla Rednam. In this video, we are going to solve the sums from exercise 13.2 from the chapter Introduction to Graphs from NCERT textbook class 8. In the previous video, we looked at 13.1 which deals with line graph. We tried to understand what we mean by line graph and how to draw a line graph for the given data. Now here in second exercise, we are looking at a particular case of line graph which is a linear graph. Let's see how it looks like once we solve the sums. So here I've taken an actual graph sheet so that the scale that I use will be similar or exactly same as the ones that you will be using, unlike the previous exercise, right? So here let's do the first sum quickly. They're saying number of apples and the cost of apples is given to us in the data, as you can see. So here clearly the first step is you will be deciding what your x-axis and what your y-axis is. So number of apples is going to be your x-axis, right? So first let me draw the x-axis and y-axis. So like I said, we have to first decide what I have on my x-axis and what is on your y-axis, right? So number of apples is going to be on my x-axis, right? So I'm going to write number of apples here. Since it is a number, there is no unit to this. And then on y-axis, I have cost in rupees. So that is my y-axis. So cost given in rupees. So the next step is I have to decide the scale, right? So you can see that the x-axis, the variation, the data variation is from 1 to 5, right? And the y-axis is going from 5 to 25. So you can take, as 1, 2, 3, 4, 5 as each 1 centimeter as one block. So 1, 2, 3, 4, 5, your data is going to end here. Now you can see that this is too short, and if you're planning on using the entire graph sheet, this looks very, the data is going to be crammed in a very little space. So we are going to take at least 2 units for the number 1, or you can take 3 as well. So let me take 2, then it is going to span up to here. Okay, so this is my origin. So I'm going to place this, I'm going to write 1 here, 2, 3, 4, 5. This is covering this direction well, quite decently. You can take 3 as well, then you would have 5 more extra blocks and you will have the data up to here. That is about your x-axis. So my x-axis scale is 2 units, or you can write 2 centimeters is 1 apple. Okay, and then I have y-axis ranging from 5 to 25. So clearly if you count the blocks here, you have 5, 10, 15, 20, and I don't have 25, right? So you can either take, 2 blocks as 5 units, in which case your data is going to end approximately, you will be using half the y-axis, right? Or you can take 3 units as 5. Then it will be 5. After another 3 units, 10. After another 3 units, you will have 15, 20, 25. Then you will be using fairly large amount of your y-axis. So let us take 3 units, right? So this is 5, and then another 3 units you'll write 10 and 15. Next you have 20 and 25. My data ends here. So y-axis I have taken as 3 units is how many rupees? 5 rupees. 3 units is equivalent to 5 rupees. Okay. So here, since we don't have any decimal figures in our data, it doesn't matter whether you take 2, 3, 4 or anything. But if you have any decimal values, then you have to be careful, because then if you have something like 5.2, then you have to decide, if there are 15 3 blocks means 30. So 30 is representing 10. So then each line will represent how much decimal part of it, that you'll have to decide. So now the next step is you're going to plot the points. So for 1 you have 5. This is the first point. For 2 I have 10. For 3 I have 15. Quite natural, right? Of course, considering or assuming that they don't have any sales where you have, usually you have offers if you buy more number of, which even your vegetable and fruit vendors do. If you buy more amount, they're going to reduce the total price for you. It is, which is going to be a win-win situation for both of you. But here it's a very plain and simple. For 1 apple, if it is 5 rupees, for 2 apples, it is 10 rupees, and so on. So you can see that when I join these points, point by point, okay, I'm actually taking 2 points at a time. You will see that it is a straight line. There is no broken line here. It is a straight line. Now, such type of line graphs are called linear graphs. This is an example of a linear graph, right? So that is your first sum. Next, let us look at this B bit, distance traveled by a car. So here the data that we have is, you have time and distance. So I'm going to take time on my x-axis, and I'm going to take distance on my y-axis, right? So let me name the axis, x-axis, y-axis. This is my time, right? And it is in hours. So in brackets, I'm going to write hours. And this is my distance covered in kilometers. So I'm going to write in brackets km. So this is the first step. Next, you're going to decide the scale. So you can see that the x-axis, the time is varying from, you have 4 sets of data, and 6, 7, 8 and 9. Like I said, we are going to take at least 2 or maybe 3 this time. Let us take 3 blocks, right? So that is 6, this is 7, and I have 8 over here and 9. So my data is only up to 9 a.m. right? So this is your x-axis. So I'm going to write the scale for x-axis as 3 units is equal to 1 hour. Of course, there's a broken line here because from 0 to 6, it is not 1 hour, and so you can put a broken line. But usually for time, even if you don't mention the broken line, it is understandable because there's no initial point of time. So that is about your x-axis. In y-axis, I have kilometers, distance in kilometers, and you have 42. The data is ranging from 40 to 160. So in the earlier sum, we have already counted that there are around 20, a little more than 20 blocks on my y-axis. So because I want 160, if I can use 16 blocks, right? And the first 4 blocks will be wasted in the sense the data is starting from 40. But nevertheless, I'll get a good spread of the data. So I'm going to take one unit as 10 kilometers. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150 and 160. So this is where my data is going to go up to. So y-axis, I'm going to write 1 unit is equal to 10 kilometers. So that is my scale for y-axis. So now let's plot the points. 6 a.m. I'm going to have 40 kilometers. So this is my point. 7 a.m. it's going to be 80 kilometers. So this is the point. 8 a.m. it's going to be 120 kilometers. And 9 a.m. it's going to be 160 kilometers. So you can actually have the corresponding these lines for each and every point that you plot, just to make sure that you don't make any mistakes. And maybe I think it's best that you draw this in order to, in the examination for each point, it's better to draw this corresponding where it is starting from in the x and y axis respectively. Now these are the 4 points. So if I join them, you will see that again what you get is a linear graph. What you have here is this line graph is linear because it's not broken at any point, right? So that is your second question. Now in the second question, they're asking how much distance did the car cover during the period 7:30 to 8 a.m. Now here I have taken 3 blocks. So 7:30 is going to be midpoint of the middle block over here. So this is 7:30, right? So if you go with this, okay, you will see that it has covered. Naturally, it will be the midpoint of these two, which is nothing but 100, right? So you will see that at 7:30 it is at 100 and at 8 o'clock it is at 120. So from 7:30 to 8, it has covered a distance of from 100 to 120, which is 20 kilometers. So that is your answer. Next question, they're asking what was the time when the car had covered a distance of 100 kilometers in this chart. Again, it's the same number that we already looked at. So if you go from here, for example, if they had as 110, then you'll go from 110 and then you look at the corresponding time. So for 100, you know that the time is 7:30 a.m. So that is your answer, right? So that is your B bit. Let's look at the C bit. Interest on deposit for a year is given to us. Okay. So here I have x-axis is going to be the deposit amount and y-axis is going to be the simple interest. Now once we plot the graph, we will look at the questions. So here you can see that, let me draw the x-axis and the y-axis. The x data on x-axis is 1000 to 5000 and 5 points of data. So you can either take 2 blocks or 3 blocks. Okay, if I take 3 blocks, I'm going to end up over here. Okay, let's take 3 blocks this time. Okay, so my x-axis is deposit in rupees. This is my x-axis. And my y-axis is simple interest in rupees. Right? So I'm going to take 3 points for each 1000. I have 2000 here, 3000 here, 4000 here, and 5000 over here. This point is 5000. Okay. Now I have the buy data ranging from 80 to 400. So like I said, we have around 20 blocks on your y-axis. So because I want 400, I can take 400 by 20 is going to be 20. So each block, if I take 20, okay, I think it's going to be sufficient. 20, 40, 60, 80, 100. So you can see this is 1/4. So I will be clearly able to cover up to 400 without any problem. 120, 140, 160, 180, 200, 220, 240, 260, 280, 300, 320, 340, 360, 380, 400. So that is my scale. So let's mention the scale first. X-axis 3 units is equal to 1000 rupees. Y-axis 1 unit is equal to 20 rupees. So that is your scale. Now let's plot the points. 1000 is, for 1000 rupees, I'm going to get 80 rupees as my interest amount. For 2000, it is going to be 160. 160 is over here. For 3000, it is going to be 240. 240 is over here. 4000, I think my scale is going to interfere with the 4000, it's going to be 320, right? And my 5000 is going to go all the way up to 400, which is over here. Okay, so I'm going to erase the scale and make space for the point, data point, right? Right. So that is your, so I'm going to write the scale. X-axis is 3 units 1000 rupees. Y-axis is 1 unit is 20 rupees, right? So now I'm going to join these points. Again, you will see that there is no broken line. That means that it is linear. Linear implies that they are directly proportional. The two parameters that we are considering, they are related and in fact directly proportional to each other, which you can verify from your formula for simple interest as well. So now let's look at the questions. Does the graph pass through the origin? I have extended it even for the previous two graphs. You've seen that it passes through the origin. So the answer is yes. Use the graph to find the interest on 2500 rupees for a year. So 2500 is going to be this point, midpoint of 2000 and 3000. So if I extend this over here, I will be able to get the interest for 2500 rupees, which is nothing but 200 rupees. So that is my interest. Okay. So A bit, the answer is yes. B bit, the interest is 200. From the graph, you can conclude that. And to get an interest of 280 per year, how much has to be deposited? So you can see that 280 is this point over here. So on the graph, you are going to go from 280 to the linear graph and then look at the corresponding point on the x-axis. So you can see that this is the midpoint of 3000 and 4000. So this point is going to be 3500. So the answer for C bit is 3500 rupees. So that is your C bit. Next, let's look at the second question. Draw a graph for the following. They're asking us to draw the graph if they have given the information of side of a square and perimeter of a square, right? And they're asking a question, is it a linear graph? All we need for it to be a linear graph is that the line is not broken anywhere, right? So let's decide what your x and y axis are and decide the scale. So this is x axis, this is y axis. X axis is going to be side of square in centimeters. Y axis is going to be perimeter in centimeters, right? And what about the scale? The data range we have is 2 to 6 on your x-axis and it's varying 8 to 24 on y-axis. So we definitely have 12 blocks, 1 2 3 4 5 6 7 8 9 10 11 12. So let us say 2 blocks equal to 1 unit. Okay, so I have 1 here, 2 3 4 5 6. So this will take care of my data on the x-axis. 3.5 is easy to locate. Like I said, when we have decimals, we have to be careful. Midpoint of these two is going to be this point simply. I'm going to write it 3.5. So that's not an issue. Next, I have y-axis ranging from 8 to 24. Like I said, we have 24, around 20 blocks. So because we have around 20 blocks, and it is kind of 24 is going to be a stretch if we take 1 unit as 1 centimeter. Also, it's starting from 8. So it is going to look a little bit redundant. So I'm going to take you know 2 units as sorry 1 unit as 2 centimeters, right? So if I do that, 12 blocks will be able to cover my data, which is around half the page, which is decent enough. Okay, so 1 unit is 2, so I have 4, 6, 8, 10, 12, 14, 16, 18, 20, 21, sorry, 22, 24. So that should cover the data, right? So now let us write the scale. Now I can write because this place is going to be empty, no problem. X-axis I have 2 units is equal to 1 centimeter, and y-axis 1 unit is equal to 2 centimeters, right? Now let's plot the points. For 2, I have corresponding to 8, so this is my point, and 3 is corresponding to 12, this is my point. 3.5 is corresponding to 14, so this is my point, and then 5 is corresponding to 20, and then I have 6 corresponding to 24, so this is 6 and this is my 24, right? So let us join the points now, 2 at a time. So you can see that it is a linear graph. So the question that they asked us, is it a linear graph? The answer is yes, it is a linear graph. Next question. I have side of square is given to us and area is given to us. So x-axis is clearly going to be side of the square and y-axis is going to be area of the square, right? So let us draw the x and y axis. In the examination, what happens, what I usually observed is, you have a lengthy paper which covers a lot of chapters and you have to attempt everything. And when you have something like, either whether it is construction or, a graph or something where you have to you come out of the mode of pen, paper and do something else, you tend to, it's a kind of a bit overwhelming. So although the questions here in this chapter are very simple and they are straightforward, students tend to lose marks usually in this topic. The only reason being, like I said, in that atmosphere, in that ambience, you find it a bit overwhelming to get away from the paper and then take a graph sheet and then do everything. So the only thing, the key to not getting lost in that or not losing marks here is that you do a lot of practice. So when you do a lot of practice, it is going to, you are going to be in a comfortable zone, even switching from your paper pen to doing the graph and not missing out any points like naming the x-axis, y-axis, writing the scale, mentioning it clearly, and also deciding, how many units for, the deciding the scale. That also, it should not be too overwhelming for you, and that is possible when you are going to, when you have a lot of, practice of it. Okay. So let's look at the data here. 2, 3, 4, 5, 6. So again, like in the previous, case, you're going to take 2 units as 1, 2, 3, 4, 5, 6. So that is my x-axis scale. What about y-axis? It is going from 4 to 36. So here if I take 1 unit as 2 centimeter square, here the unit is centimeter square because it's area. If I take that, I need 18 blocks. Okay, you'll be going really up ahead till here. So I'm not going to write the scale here. I'll write it later. So let us see. I'll take 2 blocks, or you can take 3. But the problem if I take one unit as 3 centimeters square, or 4 for that matter, is that you're going to have problem with plotting 9 and 25. So I'm quickly going to plot the points 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. So my data ends at 36. So let's plot the points. 2 corresponds to 4. 3 corresponds to 9. Now where is 9? Between 8 and 10. Midpoint of 8 and 10. So this is the point. Midpoint of 8 and 10 is 9. So that is the point. 4 is corresponding to 16. 5 is corresponding to 25. Again it is between 24 and 26. Okay. So this is the point 25. And 6 is corresponding to 36. Now how your line graph, your linear graph or any graph looks like depends on the scale that you have taken. Okay. Only thing you need to make sure is that you cover decent amount of the graph sheet proportionately. It's not too small or too large, right? So now we are going to join these points. Now I have this space left, so I'm going to write the scale here. X-axis 2 units is equal to 1 centimeter. Y-axis 1 unit is equal to 2 centimeters square. Okay, so that is my scale. So now you can see that if I join these points, 2 points at a time, you will see that extending this is not meeting my next point. I have to tilt the scale a little bit, and again extending this won't help me. I have to tilt it further. Again extending is not going to help me. I have to tilt it further, right? And if I extend it, it's not meeting the origin. So here you will say that the graph is not a linear graph. And in fact, it is clear from the fact that you know that the area of a square is side into side, okay, which is quadratic relation. It is not a linear relation. So your graph is also not linear. And if you were to plot this graph for a large amount of data, you will see that what you actually get is a parabola. Okay, what you're going to actually get is a parabola, which looks like this on the right side, on the positive x-axis side. Okay, you won't be having negative x-axis because you don't have negative sides of a square. So that is this is the part of a parabola that you got here. So with this we complete the exercise 13.2 and the chapter introduction to graphs and the entire textbook, in fact, of NCERT textbook class 8. All the chapters have been covered. I hope you find it useful, and I hope you go through them for your final exams. All the very best for your final exams. And for the exams, like I always tell you, have clarity of the concept, and you will be able to solve any sum that is asked in the exam. And also enough practice is very essential. You need to have a lot of practice in mathematics.